everyone. With the advent of the 21st century, many challenges were imposed and faced. The high demand on source of energy started to overcome the ability of production. As a result, it was so crucial to find new sources of energy which are renewable energies. Our project is about a solar energy battery. It is a battery that makes use of solar energy and converts it to electrical energy to be benefited from the charged devices such as phones. This project will combine many designs that exist with our own modifications and adjustments in a development design, and it will adopt the following engineering design process: specifications, concept development, concept evaluation, embodiment design, and detailed design.
To make any project successful, the team members should support and cooperate with each other, and this was the case of our team. So according to the team performance curve, we are now in the performance step, and after this video, we will be in the adjourn one.
We established a strategy to manage this project using a powerful tool, which is the work breakdown structure. The following table represents the WBS for our project. It contains the activities required to fulfill and achieve the goal of our product from different perspectives: functional, component, and marketing perspectives.
As presented in the chart, we can conclude that the critical part of our project lasts for 45 days. Besides, we have the task framework design that has a float of 2 days. Also, we can see that there are some interferences of tasks which required obviously a distribution of work between the teammates.
Another useful concept is to visualize the stretch of each task in time and the series of tasks. The Gantt chart can do such a task. As we can see, the tasks were ordered first by first, each one under the other, and each one took a duration in space. The purple boxes represent the duration needed to fulfill each single task, whereas the green boxes represent the unity of tasks that form a coherent phase. There are 4 unities and each contains some subunities which are the tasks.
For the functional analysis of our project, there are 3 main functions, which are catching sun rays, converting them to electricity, and finally providing charging. Different components contribute to fulfill these functions. We have panel, inverter, and power bank board. For the inputs, we have just the solar energy, and for the output, we have the electrical energy to be provided to the phones. More to discover in the embodiments part of the EDP.
The specification part divided into 4 parts. In the first part of the house of quality, we translate customer requirements into measurable technical requirements. And in the second part of the QFD, quality function deployment, we translate the technical requirements into compliant design solutions requirements. For our project, we find a solution system that catch the sun rays into and then convert to the electricity. In the third part of the quality function deployments, we translate design solution requirements into realization system requirements. And in this part of our project, we noticed that Plastic and solar panel are a good system in order to gather the sun rays and electricity, and to convert the electricity, to convert the energy into electricity. We use power bank boards. And in the fourth part of the quality function deployment, we translate the realization system requirements into a set of delivery system. Mainly these parts of this part we test that the functionality of our products, and for our project we test that panels gather sun rays and convert it to electricity. After we defined the specification parts, we built the concept development by using the morphological charts. It helped us that in our project we capture the necessary product functionality, such as we find that in order to catch the sun rays, we need a normal solar panel or a thin film solar panels. Another method that we use for concept development is the solution space tree. We use this method in order to improve the conceptual design and find out the appropriate combinations of components for our product. And also we built our concept evaluation by using Pew metrics. This method helps us to find the best solutions among different solutions, but by comparing it to the datum. And as you can see, the highest mark is the solution concept 1, and we use this solution for our final for one of our solution for one of our best solutions. And another method that we can use for concept evaluation is decision matrix. And as you can see, also according to the decision matrix, the highest mark is relevant to the solution concept 1.
And now we are in the fourth step of the EDP, which is embodiment. In this step, we have to move from paper drawings to a real-life sophisticated mockup and prototype. As you may have seen in previous steps, in specifications and in function structure, our product is a solar energy battery, which means it should cut sun rays. For that reason, we opted to use the solar panel, which has a price of 50 dirhams. It will act like an external subsystem. Those sun rays will be passed to the TP4056, which will play the role of inverter. It will convert those rays to an electricity, which will be passed by those cables to the battery storage here, fixed by the battery holder. And this stored electricity will be passed by itself to another component, which is the power booster from the power bank board. And this part will provide our phones with electricity and with charging. And all of that form what we call the internal subsystem. And concerning the external framework, we opted to use with Cartoon since it's cheap. When it comes to the price of our projects, it's relatively cheap compared to similar products because, as I said before, the solar panel is about 15 dirhams. 50. And concerning the battery, I mean the inside, all the components together form about 250 dirhams, which makes a total of 300 dirhams. And now let's move to the final part of the video, which is the final testing, in which we will test and we will show the functioning, physically built and aesthetically pleasant mockup. And now this is the final mockup, physically built and aesthetically pleasant. Here you are, here you see it. And now I'm going to test it and actually plug my phone with this cable in the battery, and it shows the signal that it's charging. You can make sure here. I can even plug and unplug if you want. Here you are, it's not charging. And now I'm going to plug it again, and it will show that it's charging actually. So that's it for today. Thank you for watching.